Lesson 3 on page C78. In this section, we are going to learn how ocean currents affect the earth, what causes tides, and how waves affect the shoreline of the earth. Let's go ahead and get started. How does the ocean water move? Splash. Think about a time that you jumped into the swimming pool. You may have noticed that the water around you moved, but have you ever thought about all the moving water in the ocean? Ocean currents. A current is simply a river-like flow of water in the ocean. You may have seen rivers flowing on the Earth's surface, but did you know that streams of water flow through the ocean? These river-like streams of water that move at different speeds are called currents. Hundreds of years ago, sailors learned where these currents are and in what directions they flow. Sailors knew that if they sailed their ship with the current, they could sail faster. Satellites that circle high above the earth take pictures with special cameras. The pictures, such as the one shown, show the different temperatures of the ocean water. Oceanographers use the pictures to trace ocean currents. Ocean currents have temperatures that are different from the water around them. Currents flowing from near the North Pole or the South Pole carry cold water. Currents flowing from the equator carry warm water. Find some of these currents on the map on the next page. Notice the arrows shown in which direction the currents are flowing. The direction of the wind and the movement of the earth cause currents that flow near the surface of the ocean. Find the Gulf Stream on the map. Notice that it flows north along the east coast of the United States. This warm current then moves east across the Atlantic Ocean to Europe. Its water warms the air that flows over Great Britain and northern Europe. Great Britain is as far north as Canada, but its winter weather is much warmer than Canada's. Let's take a look at that caption by the map. Find the cold current that flows south along the western coast of the United States. This current cools the air over San Francisco in the summer. Therefore, even though San Francisco is about the same distance from the equator as Wichita, San Francisco has cooler summers. On these two pages, it's important to understand that the ocean surface currents are river-like streams of water that flow through the ocean, and that they are caused by global winds and the rotation of the earth. It's also important to know that the currents affect ocean temperatures and as a result can affect the Earth's climates. Go ahead and turn the page. Every few years, the El Niño event changes weather patterns around the world. This event happens when trade winds don't blow as hard as usual. As a result, warm water currents spread across the Pacific Ocean. These changes prevent normal upward movement of cold, nutrient-rich water that support the food chain. Many fish die or move to colder waters in search of food. Lack of food affects the birds as well as sea lions and seals along the California coast. The El Niño also has a worldwide effect on weather. The changes in the ocean temperature cause changes in air movement and temperature. As a result, severe storms and hurricanes happen over the central and eastern Pacific. Areas around the Gulf of Mexico and the western Pacific may suffer from droughts. Notice the picture that show other effects of the El Niño event that happened between 1997 and 1998. What effects did the El Niño have on weather and climate where you live? The lack of rain in Mexico and other nearby places due to the El Niño causes the forests to be dry. The resulting forest fires in Mexico in the spring of 1998 spread air pollution into the United States and other countries. That caption down below. The warm water around the Florida Keys causes the coral to be more likely to get diseases. Touching or breaking off pieces of the coral during this time would have made the recovery harder. Scientists asked divers and people who snorkel to take extra care around the coral. Tides. A tide is the rise and fall of the surface level in the ocean. Notice the two pictures at the right. How is the ocean shore different? The pictures show what happens during a low tide and a high tide. A tide is a rise and fall of water along the ocean shore. Most places along the ocean have tides twice each day. Hundreds of years ago, people found out that the moon causes tides. People saw that 2 high tides and 2 low tides move onto the ocean shore each day. They also saw that the moon seems to rise and set each day. The moon and the earth are pulled towards each other by gravity. The pull of gravity keeps the moon moving around the earth. The picture below shows how the moon's pull on the earth causes high and low tides in the ocean. Notice that one arrow shows the pull of the moon on the ocean water. The other arrows shows the moon's pull on land. The difference in the pull from one side of the earth to the other causes the tides. It's important to know that the tide is simply the daily rise and fall of the water along the ocean shore, and that the tide occurs 4 times a day, 2 high tides and 2 low tides per day. Let's go ahead and turn the page. Waves. A wave is the up and down movement of the ocean water caused by the wind. If you blow across a dish of water, you will cause the water to move. You will see the water rise and fall, making small waves. Wind that blow across the surface of the ocean do the same thing. Winds cause the water to rise and fall as the waves pass. The picture of the ball on the water show how waves move. The water moves up and down and around, but it comes right back to where it started. The ball stays in the same place as the waves pass by. Look at the picture of the large wave. As a wave moves along it, picks up energy from the wind. When the wave comes near the shore, the bottom part of the wave is slowed down by the ocean floor. The water in the upper part of the wave is not slowed down. It falls forward and breaks against the shore. The larger the wave, the more force it carries when it breaks. Waves as those shown in the picture pound on the shoreline each day. Over time, they carry away or erode the rocks and sediments on the shore. During a storm, strong ocean waves crash high on the shore. Rocks and sand bumps into each other and wear away the surface. Waves also move sand to other places and build up sandbars. Waves can wash away parts of the shoreline of the earth. Go ahead and answer your questions on your worksheet. Thank you.